In this quick tutorial, we'll discuss the connection between the graph of a polynomial and the function it represents, specifically what the end behavior tells us about the function. The question reads, use the end behavior of each graph to determine whether the degree is even or odd and whether the leading coefficient is positive or negative. Now, just after reading the question, we know that there's a connection between the end behavior of a graph and its leading coefficient and whether the degree is even or odd. And we read up here that the end behavior depends upon the leading term. So what does that all mean? So let's pretend that we graphed a polynomial on an xy plane and it turned out to look like a parabola. The end behavior is what the graph looks like as x gets larger. And as it gets larger, this tends to go up to infinity. This part right here represents the end behavior. And it turns out that if it's pointing up, then the leading coefficient of the polynomial is positive. So we'll call the leading coefficient a, and it will be positive, so it's greater than 0. Now with that being said, look at the other endpoint. If it's facing in the same direction, then we say that the degree associated with the leading coefficient is even. So I'll write down degree even in this example. Let's move on to the very first example in our question. Here the endpoint is facing down, so expect a to be less than 0, expect it to be negative. On the other hand, this end is facing in the opposite direction. So the degree of that leading coefficient term should be odd. Odd as in 1, 3, 5, etc. In this example, the endpoint is facing up, so expect a to be positive. And this one is going in the same direction, so the degree is even. And so with what we learned, you can use that to determine the end behavior of a polynomial function when it comes to sketching a polynomial based on key features.